So, good morning, all of you. In the continuation of this renewable energy resources, today we will come to the Unit 5 and will cover the topics of this Unit 5 in renewable energy sources. So, in Unit 5, you will discuss about the biomass and the ocean thermal energy convergence, biomass, ocean thermal energy convergence, wave and tidal wave. Its availability, convergence theories, performance limitations. We will discuss about all these in this Unit 5. Okay. So, first of all, biomass, its introduction, availability of biomass, working, what is the working, then types of biogas plants, that is floating drum type or fixed drum type, or Deenbandhu biogas plant. These are, we will discuss about all these things, and the material for the biogas and the site selection, then merits and demerits of this biogas, then ocean thermal energy conversion, that is OTEC, its introduction, OTEC plant designs and location. We will discuss about these things, and its convergence, ocean thermal energy convergence we will discuss, wave and tidal waves we will discuss, its introduction, availability, classification, merits and demerits and limitations we will discuss about these things. First of all, the biomass. What is the biomass? As the name suggests, biomass is the energy which is generated because of the waste, due to the combustion of the waste. So, this is the cycle of the biomass. Like from the trees or plants, when it get decomposed, so through chairs and cartoons are formed with these plants or trees, and with these wood products the biomass is get produced, which is utilized in the biomass power plants, and this CO2 is getting emitted out with this power plants, and this CO2 is consumed by the trees and the plants, and it's the again process will continues up, like wood products are formed due to these trees. So, this is the cycle of the biomass, how this biomass are created and utilized, and again that decomposed in the released in the CO2 form to give the trees and plants. Okay. So, biomass is an organic material made of from the plants and animals, as we saw in the last, and it is a renewable energy source because we can always grow more trees and crops, and waste will always exist, and it does not include the fossil fuels which take millions of years to create, and when burnt the chemical energy in the biomass is released as a heat. Okay. And wood waste and garbage can be burned to produce the steam for making the electricity, or to provide the heat to the industries and the homes. And burning biomass is not the only way to release its energy. Okay, burning of biomass is not only the way to release its energy, and it can be converted to other usable forms like methane gas or fuel such as ethanol and biodiesel. Okay, so these are the biomass, and biomass plant is a device for conversion of fermentable organic matter, in particular cattle dung, into combusting gas and fully matured organic manure. The main sources for production of biomass are cattle dung, night soil, poultry or piggery droppings. Then these materials are confined in a place out of a contact with oxygen, give rise to a large number of bacteria which converted carbon hydrate, protein, fat into volatile and carbon dioxide, while biomass is organic matter derived from plant, algae, animals, etc. Then traditional use of biomass is more than its use in modern application. In the developed world, biomass is again becoming important for applications such as combined heat and power generation, and in addition biomass energy is gaining significance as a source of clean heat for domestic heating and community heating applications. This biomass energy is gaining significance, and in fact in countries like Finland, USA and Sweden, the per capita biomass energy used in is higher than it it is in India, China or in Asia. Then instead of burning the loose biomass fuel directly, it is more practical to compress it into briquettes, that is compressing them through a process to form the blocks of different shapes and thereby improve its utility and convenience of its use. Okay, so this is the biomass working, and such biomass in the dense briquette form can either be used directly as a fuel or instead of a coal in the traditional chullas or and furnaces or in the gasifiers. And gasifier converts solid fuel into a more convenient to use gaseous form of fuel called the producer gas. Okay, so this is the gasifier, and so this is the conversion processes like digester, the CH2 and CO2 digester gives to minerals and to the photosynthetic units, that is algae and hatching to the fish pond. So this is the conversion process. Then the types of biogas plants are like fixed dome type, modified fixed dome type, floating dome type. These are the types of the plants. And the biogas plant consists of the two components, a digester or a fermentation tank and a gas holder. Okay, and the digester is a cube shaped or cylindrical waterproof container with an inlet into which the fermentable mixture is introduced in the form of a liquid slurry. And the gas holder is normally an airproof steel container that by floating like a ball on the fermentation mix then cuts off air to the digester, that is anaerobics, and collects the gas generated. In one of the most widely used design, that is the figure 2, this is shown. The gas holder is equipped with a gas outlet while the digester is provided with an overflow gas digester is provided with an overflow pipe to lead the sludge out into a drainage. Okay, so this is the thing. Then working of the biogas generator or biogas plant. To understand the working of the biogas generator or biogas plant, please refer to this. This is the fixed dome type. Okay, and here are various steps of working of biogas generator or the biogas plant. In the mixing tank, the water and the cattle dung are mixed together thoroughly in the ratio of 1:1 to form the slurry. This slurry is then transferred to the digester via inlet chamber up to the cylindrical portion level of the digester. Okay, up to the cylindrical portion level of the digester. The fermentation of the slurry starts in the digester and the biogas is formed, which is accumulated at the top of the digester in the dome. Since the outlet gas valve is closed in this, so the biogas exerts pressure on the slurry, which starts moving in the inlet. Okay, it starts moving the inlet and the outlet chamber, due to which the level of the slurry drops in the digester and increases in the outlet chamber. Okay, then this is the thing. If the biogas outlet valve is further kept closed, the level of the slurry further drops in the digester. The level of the slurry further drops in the digester due to the gas pressure. The slurry reaches to the highest possible level in the inlet and the outlet chambers, and if the gas valve is still kept closed, the biogas will further get accumulated in the dome, and its pressure get increases. Eventually its pressure becomes the high enough and it starts escaping through the inlet and outlet chambers to the atmosphere. It starts emitting out to the atmosphere. Then during its escape, the biogas creates bubbles in the slurry in the inlet and outlet chambers, and there is also a formation of the froth. Then the increase in the volume of the slurry in the outlet and inlet chambers helps you to calculate the amount of biogas which is getting generated in the digester. If you want to use the biogas, you can open the valve of the gas pipe and remove it as per the requirement for the various applications. And when the gas is taken out from the dome, the level of slurry in the digester increases, while the inlet and the outlet valves get reduces. And when the gas is not being used from the dome in the digester, okay, is not used in the dome of the digester, the level of the slurry in the inlet and the outlet chambers, the level of the slurry in the inlet and the outlet chambers will be very high, and intake of this fresh slurry in the digester is getting reduced. Then in floating drum type biogas plants, the floating drum type plants were mainly built in India, and floating drum plants consist of an underground digester and moving gas holder, and the gas holder floats either directly on the fermentation slurry or in a water jacket of its own, and the gas is collected in the gas drum, which rises or moves down according to the amount of the gas stored, and the gas drum is prevented from tilting by a guiding frame. Then the drum in floating drum type biogas plant, the drum in which the biogas collects has a internal or external guide frame, provides stability and keeps the drum upright. Okay, it keeps the drum upright like in this way, and if the biogas is produced, the drums moves up. When the biogas is produced, the drums moves up if the gas is consumed, and the gas holder sinks back. A common floating drum type biogas power plant in India was suggested by the Khadi and Village Industries Commission, KVIC. Okay, so this is the form. So this is the mixing tank which is get mixed in this, and the biogas is this is the biogas collector, and the outlet that is biogas is produced in this way. Okay, then next is the fixed dome type plants. A fixed dome type plants consist of a digester with fixed non-movable gas holder which sits on the top of the digester, and when the gas production starts, the slurry is displaced into the compensation tank, and the gas pressure increases with the volume of the gas stored and the height difference between the slurry level in the digester and the slurry level in the compensation tank. And there are also no rusting steel parts, and hence a long life of the plant, that is 20 years or more, can be expected in this. And the plant is constructed underground, protecting it from physical damage and saving space. And while the underground digester is protected from low temperature at night, and during the cold seasons, the sunshine and the warm seasons take longer to heat up the digester. Then no day or light fluctuation of temperature in the digester positively influence the bacteriological processes. Then the Janta model is the basic fixed dome type plant in India, was developed by the Planning Research and Action Division, Lucknow, in 1978, and it is the first fixed dome type plant based on the Chinese technology. Then these are the differences between the floating drum type and the fixed dome type plants. There are certain advantages or disadvantages of floating drum type. Like advantages of floating drum type are like it has a constant gas pressure, higher gas production, less danger of explosion due to the separation between the biogas and the external air, and no problem of the gas leakage. And disadvantages of the floating drum type are it has a higher cost, higher maintenance is required, loss of heat through the gas holder. And in the fixed dome type plants, there are advantages like less maintenance due to no moving parts, low operating and capital cost. Then heat insulation is better due to its underground construction, and it has a longer working life in fixed dome type. And certain disadvantages are like gas pressure is variable, required skilled professionals for the construction, and scum is formed. Okay. Then next is the Deen Bandhu biogas plant. The mixing tank is fed by the biomass and the water for making the slurry, feed slurry by stirring with the stirrer. The slurry is fed into the digester through also for mixing the slurry, and there is a stir arrangement in the digester also for mixing the slurry. And the generated biogas is collected in the fixed dome type upper half of the digester tank, and through the outlet, the pipe, the gas is delivered in to the consumer side. The residual spent slurry is discharged out from the digester and used as a manure, and this spent slurry is discharged by opening the damper attached and the discharge window with the discharge window. And depending on the shape of the digester dome, there may be variation of the type of the biogas plant. And in case of fixed dome type plant, the upper dome is fixed in this. So this is the form, this is the digester, okay. And the biogas plant, Deenbandhu biogas plant, the biogas is formed in this area, and the cogeneration unit is attached here with automatic control unit for its controlling, and this slurry is fed up into this through this digester, okay. Then these are the material used for the biogas generation, that like crop waste, animal waste, municipal waste, agro industry waste, then forestry litter, aquatic sources. These are the different material used for biogas generation plants, okay. Then next is the site should facilitate easy construction. Site selection which should be taken care of for the biogas plant, that the site should facilitate easy construction works and should be such that the construction cost is minimized, and the selected site should ensure easy operation and maintenance activity like feeding of plant, use of main gas valve, and composing and use of slurry, checking of gas leakage. These should be taken care of, and draining which is drained out, it should be condensed water from the pipeline, etc., to make plant easier to operate and avoid wastage of raw materials, especially the dung swine manure. Plant must be as close as possible to the cattle shed, okay. Then the site should be slightly higher elevation than the surrounding. This helps in avoiding waterlogging. This also ensures the free flow of slurry from the overflow outlet to the composting pit. And for effective functioning of the biodigester, the right temperature, that is 20 to 35 degree, has to be maintained inside the digester, and therefore it is better to avoid the damp and the cool place. Then select the open slurry site to get the maximum efficiency of the biogas plant. Then select the site near the kitchen to avoid the condensation and other problems, and select the size according to your waste generation, availability of air and use. Then next is the placement of the biogas plant. Keep the biogas plant with care and keep the outlet of the slurry as per your convenience to collect and handle the rich slurry for manure, and provide some container channel to collect and use the slurry from the outlet. Then there are certain merits of this biogas energy, that it has a very high cost of obtaining bioenergy through the plantation is lesser than cost of obtaining energy from the fossil fuel. So it has a very high cost of obtaining bioenergy. Then plant ensure a continuous supply of energy due to their continuous growth. Then combustion of the biomasses does not cause the SO2 air pollution, since the content of the sulfur is in vegetable is even less than 0.1%. Then growth of biomass consumes more CO2 than is released during the combustion, besides producing the atmospheric purifying oxygen product of the photosynthesis process. Then biomass is a perennial and low polluting type of energy. All its byproducts are capable of being recycled. Then certain demerits are also there, like accumulation of water in the pipeline and need to remove it at a periodic intervals. Then inefficient designing of the gas appliance. Then the seasonal variation in gas production due to the lack of temperature control and poor insulation of the plant. And on absolute basis, the cost of biomass energy is found to be generally than a coal based plant. These are the demerits of this biomass energy. Next is the ocean thermal energy conversion. Ocean thermal energy conversion is a process of technology for which producing energy by harnessing the temperature differences, that is thermal gradients between the ocean surface waters and the deep ocean waters. Then energy from the sun heats the surface water to the ocean, and in tropical region the surface water can be much warmed than the deep water, and this temperature difference can be used to produce the electricity and desaline ocean water. Then ocean thermal energy conversion systems use a temperature difference of at least 77 degree Fahrenheit to produce the turbine to produce the electricity. So this is the ocean thermal energy conversion, where this is the OTEC plant. This is the cold water which is getting intaked, and these are the offshore OTEC future, and this is getting consumed to the onshore OTEC system. So it produces the 100 kilowatt of power, around 120 Hawaii homes powered by this seawater. Then warm surface water is pumped through an evaporator containing a working fluid, and the vaporized fluid drives a turbine generator, and the vaporized fluid is turned back to a liquid in a condenser cooled with the cold ocean water pumped through deeper in the ocean. Then OTC systems use the seawater as the working fluid and can use the condensed water to produce the desalined water. Then the water temperature differs between the warm and the cold layers must be at least 20 degree different. As the ocean goes away from the land, it creates a slope leading to deep water that is warm on top and cold down in the deep, and this is the perfect place for the ocean thermal energy conversion process. The different temperature between the two layers of the ocean are very common in tropical climates, and these areas makes the perfect location for OTC plants to be effective and efficient. Then ocean thermal energy conversion can be done using the different or several systems. Three of most common are the OTC processes are like closed cycle system and a hybrid cycle system, and an open cycle system. The oceans are thus a vast renewable resource with the potential to help us produce billions of volts of electric powers, and this potential is estimated to about 10 is about 13 watts of base load power generation, according to the some experts. And the cool deep sea water used in the OTC process is also rich in nutrients, and it can be used in culture, both marine organisms and plant life near the shore or on the land. All OTC plants requires an expensive large diameter intake pipe, which is submerged in a kilometer or more in the OTC depth to bring very cold water to the surface. Then depending upon the location, land-based and near-shore facilities. Land-based and near-shore facilities offer three main advantages over those located in the deep water. Plant constructed or on or near land do not require sophisticated mooring, lengthy power cables, or more extensive maintenance associated with open ocean environments, and they can be installed in sheltered areas so that they are relatively safe for storms and heavy seas. Then these are the shelf-based plants. Shelf-mounted plant could be built in a shipyard to towed to the site and fixed to a sea bottom. This type of construction is already used for offshore oil rigs, and the additional problems of operating the OTC plant in deeper water, however, may make the shelf mounted facilities less desirable and more expensive than their land-based counterparts. Then floating plant or floating OTC facilities could be designed to operate the offshore. This type of plant is more difficult to stabilize, and difficulty of modifying it in very deep water may create problems with power generation or power delivery. Then open cycle or open thermal energy conversion system has a merit to use a heat exchanger of direct contact type without a heat transfer tube. Therefore, it is expected that capital cost of OTC is reduced by use of this simply designed heat exchanger. However, non-condensable gas is released in the system because in a direct contact evaporator, the steam driving a turbine is generated by a surface seawater, including air and existing air, causes a reduction of system performance. Then from the above point of view, we carried out an experimental study on the operating characteristics and the effect of the structure of the heat exchanger and the existence of the non-condensable gas on the performance of a desired contact heat exchanger in an experimental apparatus of the barometric type OTC. So, this is the OTC diagram. OTC cycle uses a warm surface water directly to make the electricity. The warm seawater is flashed evaporated into a low pressure container, which causes it to boil. And in some schemes, the expanding steam drives a low pressure turbine attached to an electrical generator. So, this is the warm water which is entered into the evaporator, and it falls on the steam turbine to the generator, and through the steam turbine it goes to the condenser, and after condensing it is recirculated back to the ocean. This is the open cycle, and in open cycle OTC system, warm seawater is the working fluid, and the warm seawater is a flash evaporated in a vacuum chamber to produce steam at an absolute pressure of about 2.4 kilopascals. The steam expands through a low pressure turbine that is coupled to a generator to produce the electricity, and the steam exiting the turbine is condensed by a cold seawater pumped into the ocean's depth through a cold water pipe. And if the surface condenser is used in the system, reused in the system, the condensed steam remains separated from the cold seawater and provides the supply of the desalined water. Then next is the closed cycle OTC system. In closed cycle, the low boiling liquid such as freon or ammonia is the working fluid. The fluid is evaporated using the warm surface water, seawater. After the vapor drives the turbine, it is condensed by the cold seawater. This condensate is pumped back to the evaporator. The heat of surface of the water having temperature from 27 degrees Celsius to 30 degrees Celsius is transferred to the evaporator. Warm surface water vaporizes ammonia, and ammonia vapor produces the work while expanding in the turbine. Then in closed cycle OTC, a working fluid with a low boiling point such as ammonia or propane is circulated. Okay, it is getting circulated, and warm surface seawater is pumped back through a heat exchanger where the working fluid is vaporized and driven through a turbine, which then generates the electricity, and cold deep seawater is then pumped through a second heat exchanger where the working fluid vapor condenses back into a liquid and recycled through the system. So, this is the closed cycle OTC system. Closed cycle systems use the fluid with a low boiling point such as ammonia, freon, 12 butane to power a turbine to generate the electricity, and warm surface water is pumped through a heat exchanger which acts as a boiler to vaporize the fluid at a high temperature. So, this is the system of the closed cycle OTC system. Here we can see that when the heated water comes to the condenser, it gets recirculated to the recirculated to the evaporator, and some cold deep water is extracted from the ocean and condenses back to the ocean. So, this is the closed cycle OTC system. So, in this lecture we have discussed about this closed cycle and open cycle OTC system. So, thank you so much, and we will continue in the next class with other topics which are left.